Hello YouTube, I'm Mr. Way4Out, and in this episode I will be teaching you how to create a networked tic-tac-toe game. So I'll go ahead and start off here by showing exactly what we are going to be making. So as you can see, it is asking for our IP and then for the port, of course. And I went ahead and bundled the server and the client application into one application. So this one here will be our server. As you can see, it says unable to connect to the address, so it will start the server. This one will be able to connect to that address, so it will become the client, and it'll say I successfully connected to the server. So we can go ahead and start playing our nice game of tic-tac-toe here. And good, nice game of tic-tac-toe, and when you win it says you won or your opponent won. Now as you'll notice, on this one the X's are blue and on this one they're red. I just kind of took it, as red being like the enemy and blue being the ally, or like yourself. So that's why I did it the opposite colors. So anyway, now we can go ahead and jump into the code. So let's go ahead and start off here by, of course, creating our new Java project, and I will call this Tic-Tac-Toe. Tic-Tac-Toe. And let's create our package. New package. A little slow, there we go. Oh, there we go. New package. com.MrWayFarOut.tic-tac-toe. And we'll create our class, which will be Tic-Tac-Toe. Alright, so once that pulls up, here we go. Let's go ahead and start off by creating our main method, so public static void main string array args. And above that we'll go ahead and create the constructor for the class, which will be a public tic-tac-toe. And down in main we will go ahead and say that tic-tac-toe equals new tic-tac-toe, and right above that we'll do an @suppress warnings unused. Alright, now the first thing that I want to go ahead and start off by doing is creating a boatload of variables for this game. So the first thing will be a private string IP, which will be equal to localhost by default. The next one will be a private integer port, which will be equal to the 52s by default. We're going to need a private scanner, which will equal a new scanner with system.in as the parameter. And as you noticed when I ran that thing, it asked for the IP, and that is what the scanner was handling. The scanner is taking the import. So we create the scanner and we're taking it because we want the input. We are throwing in system.in as our input stream. We are going to want a private JFrame frame. We're going to want a private final integer width, which will be equal to 0, and a private final integer height, which will also be equal to 0. Import JFrame, that is a Control-Shift-O to import. And actually the width will be 506, and this will be 527. I'll go more into that once we get farther into this. So the next thing I want is a private thread, and while we're at that, let's go ahead and make this class implements runnable, and then let's go ahead and create a public void run method, because that is required when you are implementing runnable. Alright, some more variables. I want to go ahead and create a private painter, and no, this will not be the java.ot, I think it is. No, the javax.swing.painter. We're actually going to make our own, so let's go and write that here. Public class painter, no parentheses. Alright. I also want a private socket, a private data output stream DOS, a private data input stream dis, so dis and DOS. Alright, Control-Shift-O, and we want the java.io.data input stream, and we want the java.io.data output stream. And so what the socket is, the socket is the thing that's going to connect to the server. So when we have, say, two sockets, sockets can connect to each other. Let's see what the documentation says. Client sockets, just as I said, and it is an endpoint for communications between two machines, if that makes any sense. So it is the thing that will be communicating with the server will be communicating with it, and it is the endpoint, so what data is going to and out, but between two machines, so it is just the implementation to communicate over a network through two machines in Java. Data output stream is just the data output stream that lets you write the primitive data types. to an output stream, which will be written to our socket, and the input stream does the same thing, but with inputs. Alright, next thing I want is a private server socket, and the server socket is just like a socket, but this is for the server side. You know, this one waits for a request to come in, and then it performs some operation based on that request. And we'll get more into that. Next thing I want is a private buffered image board. I want a private buffered image red X. I want a private buffered image blue X. I want a private buffered image red circle. I want a private buffered image red X. Alright. What did I do? No, this will be a red, this will be a blue circle. Blue circle. Import buffered image. Alright. I'm going to want a private string array called spaces, and this will be equal to a new string array with 9. So, some of you might be wondering why 9, and so if we go and look at our tic-tac-toe board, there's 9 spaces, and so when we change that into an array, there is still 9 spaces, but the index will start at 0, of course. So this will be 0, this will be our 1, this will be 2, 3, 4, 5, 6, 7, 8, and that is, of course, 9 squares again, and so that is where I'm getting the 9 from. We're just making it of size 9. Alright. I'm going to want a private boolean your turn, which will be equal to false, a private boolean circle, which will be equal to true, a private boolean accepted, which will be equal to false, a private boolean, this one's a mouthful, unable to communicate with opponent, which will be equal to false. We want a private boolean 1, which will also be equal to false. We want a private boolean enemy 1, which will be equal to false. Next I want a private length of space equal to 160. I want a private integer errors, which will be equal to 0. I want a private integer first spot, which will be equal to -1. I want a private integer second spot, which will be equal to -1 as well. Alright, so the length of the space is just simply on our board here. That is the area here, and here, and here. All these are 160 by 160, or at least something close to it. I'm not sure if it's precise. Yeah, that one's 159 by 159. But more onto this. No, we'll get to that later. But the length of the space is just these spaces, obviously. Errors, when there's an error, we'll just increment that, and once that gets to 10, you know, that's way too many errors to like continue our game because something's going wrong. So then we'll set unable to communicate with opponent to true, and we will throw the error. First spot, second spot. When I finished that tic-tac-toe game, you saw that it drew a nice little line between the spot that I won at, like right through here. And so, is that seriously? Oh, Control A. It drew the nice little line through here saying you won, and then it drew the spaces, and our first spot would be equal to this square right here, and our second spot would be equal to the square over here. And so that was what the first spot and second spot was doing. That was just a placeholder so we know where to render them at. Alright, Control Z, undo all that. Pause. No, I don't want to save that. Cancel. Alright. Let's go ahead and keep making these variables. I want a private font, which will be equal to a new font of type Verdana. I will be font.bold. And 32. I want a private smaller font, which will equal a new font as well, still of type Verdana. It will also be font.bold. It will be of size 20. I want a private font, larger font, which will equal to a new font of type Verdana. Font.bold. I always make my fonts bold for some reason. I don't know. I don't know. Makes it easier to see maybe, but I do that anyway. Okay. Next, I want some strings here. So private string waiting string, which will be equal to waiting for another player. I want a private string unable. This is a mouthful again. Unable to communicate with opponent. string, which will be equal to unable to communicate with opponent. I want a private string 1 string, which will be equal to u1, and then I want a private string enemy 1 string, which will be equal to opponent 1. Alright. We have more variables to make, but that's for now. As you've noticed, I've been making all of my variables private, and you know, it's just good programming practice to start all your variables off as private and then move up the ladder as you need to make them more visible, or more visible, because you're starting off at the least visible level. So if we do need to, then we could change them to protected, or then to package private, and then to public if we really need. But by default, you know, it's just good programming practice to make them all private by default. So now in our tic-tac-toe thing here, we are going to go ahead and system.out.println, go ahead and say please input the IP, and here we will use our scanner, and we will say that IP is equal to scanner.nextLine. Then we will system.out.println, please input the port, and then we will do port equals scanner.nextInt. And then I want to create a while loop here and say while the port is less than 1 or the port is greater than 65535. And this is just some port checking here, because as we know, or as you may or may not know, ports can only take on the values of a short and only positive short. So, and I'm pretty sure 1 is reserved also, but who cares about that? So we have to make sure that the port is not less than 1 or greater than 65535, because then, you know, we can't start a server there because that port does not exist. So while this port is less than 1 or greater than 65535, we'll go on to system.out.println. The port you entered was invalid. Please input another port. And then we will say that port is equal to scanner.nextInt. That will handle that. And I'm not checking to make sure the IP is good, because IPs can be so many different things, from like localhost to like website domain names to like 192.168.1.1 or whatever, and just too many different things to check, you know. I mean, we could, but there's a lot of things to check, so you know what, screw that. Who cares? We'll just count on the honor system for them to get a working IP. The next thing I want to do is go ahead and load our images, so we'll go and create a method called loadImages, and I'll go ahead and make that down here. So private void load images, and let's go ahead and go into our folder that contains our project here. So this is my new YouTube workspace, and into Tic-Tac-Toe I want to create a folder called res, short for resources, and in here I want to go ahead and drag the images I have already made, because I don't want to waste your time making those images. So let me go find these. There you go. Resources, and control paste. Maybe. Alright, there we go. So you probably want dimensions for a lot of those things. So for the board, this is 500 by 500 with a space is 160 approximately, 159 for some of these. All these resources will be on a Dropbox links in the description if you just want to download these rather than making them yourself. But if you do want to make them yourself, you also want to know the width of this little black bar here, and that happens to be 12. Happens to be 12. Make sure I got that right. Okay, come on, scroll over. Yeah, it's 12. And then that will also be the height of the horizontal bars. Into our X and our O's, these are 100 by 160, and there is a probably 10 border between the X, or about 10. This one's 10. There's a 10 border between the edge and where the X starts, and that would be the same thing with the furthest part for the O. As I said, all these images will be in the link, or link in the description, and so you can just use that. That's just as easy. So then we'll come back here and we'll go and refresh this, and then I want to right click on our project, go to build path, configure build path, and then we want to add a class folder, and we will go and check mark resources, hit OK, and there will be a little book on the folder, and it will also pop up with this reference libraries, and res will be in there. So now we can start using that. Oh, there's resources in our project here. So in load images, let's go in and say that try catch here. Try catch IO exception called E, and E dot print the stack trace. And then here we want to go in and say that board is equal to image IO dot read get class dot get resource as stream, and this one is slash board dot png. Don't forget the png, that's important. We can go ahead and import image IO and IO exception, as a matter of fact. Next, let's do redx. Redx will be equal to image IO dot read get class dot get resource as stream, and this is slash redx dot png. Next one will be red circle, which will be equal to image IO dot read get class dot get resource as stream, and that is slash red circle dot png. Next one is blue x, which will be equal to image IO dot read get class dot get resource as stream, and this is a slash blue x dot png. Next one is blue circle, which is equal to image IO dot read get class dot get resource as stream, and that is slash blue circle dot png. That is all the images we will need for our game. Oh, and another thing, as you can notice, I never actually oh, that's frustrating. I'm gonna go in and change something here for my formatter. So properties, no, yes, maybe code style formatter. Here we go. As you notice, this thing had no GUI. I will leave that up to you because I did not want to make a GUI. That's a lot of waste of time, and it's pretty easy, so I'm sure most of you could do it. And I'm going to go in and create a thing here for my formatter. Control-Shift-F is to format, by the way, and I find this very helpful. But I need it to be done a certain way. Let's just change something like 800. Apply, okay. Apply, okay. Apply, okay. Here we go. Alright. Back up here, let's go in and say, back in our tic-tac-toe constructor, we'll say that painter is equal to a new painter. And we will say painter.set preferred size to a new dimension width, comma, height. Spelled height wrong. Did I? Yeah, I did. Height. There we go. And delete that. Alright, so down, import dimension. Alright, so down in our painter class, we want to go in and create this thing. And so this, we can actually make this a private class, because this is the only class that's going to be using it. This thing will extend, what was that? Alright, this thing will extend JPanel, and it will also implement a mouse listener. And so we can go to import both of those things, and then this will want to add the unimplemented methods. Once we spell mouse listener right, it will want to import the unimplemented methods, which we will go ahead and do. And we can go ahead and remove this to-do auto-generated method stub, not the method itself. Okay, there we go. The to-do auto-generated method stub. We can leave the add overrides. So then, the first thing I want to do is, this thing is going to want a default serial ID. We can just add that real fast. Get rid of the warning. We're not making the serialized matter. You don't really need to worry about that. So, now public painter set focusable to true. This is so it can receive key events and like mouse events and stuff. We want to request focus. We will set the background to color.white. Once you spell color right. Import color, and we will add a mouse listener and this, because this is our mouse listener because we're implementing it. Now here I want to do an at override annotation, and we will create the method public void paint component, and this method takes in a graphics G, and this method is located inside of our JPanel. And then that's cool. I'll just cut that out. So, in our run method here, what else do we need? I want to go ahead and say in our run method, we're calling the painter.repaint. So, if we are not a circle, and we have not accepted, then we need to listen for server request. So if we are not a circle, meaning we're the server, and if we have not accepted a client, then we need to listen for the server request to see if anyone is trying to join our server. So let's go and create this method. So private void listen for server request. We want a socket which will be equal to null, and then we want a try catch block here, and this will catch an IO exception E, and we will print the stack trace if we have a problem. And now let's fix all these errors are made. Number one, we need a colon or a semicolon there. Let's format this. Let's spell catch right. There we go. And print the stack trace. Trace needs to be capitalized. Alright. Print stack trace. Print. What am I doing wrong? Print stack trace. Okay, no, it was right. I don't know. Alright. So in this try block here, when we are listening for the request, we need to go ahead and say socket is equal to server socket, which should be lowercase, my bad. Server socket dot accept. And DOS will be equal to a new data output stream, socket.get output stream. Goodness, cannot type output stream. We will say dis is equal to a new data input stream, socket.get input stream. We can say that accepted is equal to true, and we will system.out.println that client has requested to join and we have accepted. So that is the listen for server request method. And this method simply listens for a request on the server, and the server will accept it once we get one. And listen for server request. Which one? Listener? No, we want listen. There we go. Alright. So let's head over to our tick method. So let's go ahead and say if errors is greater than or equal to 10, let's set unable to communicate with opponent equal to true. And you know what? Back up here. I spelled that wrong, did I? Change to unable to communicate with opponent. Unable to communicate. Oh, I spelled it wrong. Alright. Let's back up here. Many of you are probably wondering, is this game running off a TCP or UDP connection? And we're going to go into the basics of these real fast. So a TCP connection is a transmission control protocol, which a TCP connection ensures that the data is sent and that it is received, and it is received in the right order, and its integrity is still there. Because a TCP connection does something called a handshake, which essentially means once it gets sent, then we have to wait for the client to send something back, that's called a handshake, to say that, this is what I got, and is it good, is it right? And that is what the handshake is doing. And if the handshake passes, then we can use the information. So a TCP guarantees that it will get there, it guarantees it will get there in the order it was sent, and it guarantees that it will keep its integrity. UDP, on the other hand, standing for User Datagram Protocol, this one, it does not guarantee that it will get there. It does not guarantee that it will get there in the order that it was sent, and it does not guarantee that it will keep its integrity. So some of it may be lost along the way. That goes along with that, it does not guarantee that it will get there. So many of you are saying, well, TCP is the obvious thing to go for like everything. Well, that's not true. For many things like games, the Cherno Project explained this brilliantly in one of his episodes, and he said that, if we were using a TCP connection on, say, like Call of Duty Black Ops, then when you're playing it, and if you start getting behind, you start lagging a bit, but everybody else is perfect, then you're 2 seconds behind the game. You're lagging 2 seconds behind, and that's really bad. So instead, they use a UDP, because, it can still be sent, it's generally reliable, and, that can be sent, and that will keep you up to date, and it will discard the old things. So, you know, we're staying up to date, we're staying with the server, and everyone's on the same, or at least within a very small latency of each other. So back to that TCP UDP. TCP is really good for turn-based games like Tic-Tac-Toe here, and that is why we are using a TCP connection, because we are not using a user datagram packet. So TCP is good for like turn-based games, or when you have to ensure that something gets there. So let's take Call of Duty again for example. Like when you're playing multiplayer and it has to load everything, most likely that's a TCP connection, because it's sending all the data for the players, all the data for the map, all the objects, all the guns, all that stuff, and that stuff has to get there. Like, that's not an option, because, you know, you can't be walking around in a blank space if you don't have a map. But then once you are in the game, it will probably switch to UDP just to make sure, you know, no one gets behind the game. And so I just wanted to talk about that real fast. So let's go back into our tick method. And what is this? Oh, it's not going to keep simple ifs on one line. Well, let's change that real fast. Sorry. This was a new workspace, as you could tell. So let's go into probably indentation, braces, white space, brace, blank space. Oh, control standards. Here we go. Keep simple if on one line. Keep then. Keep simple if. Here, you know what? Alright. If true, return, else if. What does that one do? Yeah, we want that. Keep return. No, we don't want that. Else return. Okay. Sorry about that. There we go. That looks better. Alright, so back into this tick method, what we want to do after we have done that, we can go ahead and say, if it is not your turn, and we are not unable to communicate with opponent, then we will try, and we will catch an IO exception, E, and we will E.print the stack trace. Goodness, stack trace, and we will do errors plus plus. And back up here, we want to say integer space is equal to dis.readInt, read integer. Oh, that reminds me. Back into our initialize server method, or no, our listen for request. This thing right here, socket is equal to server socket.accept. It is important to note that this accept method will block until it gets a return value. So it listens for a connection to be made on the socket and accepts it, and this method blocks until a connection is made. So our game will stop everything it's doing once we get to this line, and it will wait until we have another person there, or until we receive a connection on the server socket to begin. That's important to note. Alright. Back into our tick method. Sorry about that, I'm just jumping around a bit. We can go ahead and say that spaces space is equal to, actually no, we want a if statement here, sorry. So if we are a circle, then spaces space will be equal to x, and else we will say spaces space equal to O. And then we will check for enemy win, because our enemy just won, so we can check to see if they won, and then we will set your turn equal to true. Alright. What else should we do? We should probably work on a render method, because, you know, games are no fun unless we can actually see stuff on the screen. So let's come to our render method here, and we can go ahead and start by saying g.drawImage, and let's draw the board at 0, 0, null. That will draw it at 0, 0, and we don't have an image observer. Next, we want to say if we are unable to communicate with opponent. So if we aren't able to communicate with the opponent, then g.setColor, color.red, and let's what do we have to do? We are going to, I think we want to use the smaller font. G.setFont, smaller font, and graphics 2D. This is a helpful thing I'm going to teach here. Graphics 2D, graphics 2D, G. So we're creating graphics 2D object off of our graphics object. And we are going to want to say that g2.setRenderingHint, and this will be a renderingHints.key _ text anti-aliasing, comma rendering hints dot value underscore text underscore anti-alias underscore on. So this will kind of remove like the pixelation of the text, like how this text is nice and smooth. When you have bigger text, you know, it could get a little pixelated. You just have to see it kind of to understand that. But when text gets so big, it's kind of pixelated. So instead, we're going to smooth it out, and that is what this text anti-aliasing will do for us. Alright. Then I want to say integer string width is equal to g2.getFontMetrics. This is a cool thing that we're going to do here. G.getFontMetrics dot string width unable to communicate with opponent string. So this method here is going to tell us how long exactly this string is in the font we're using. That's really helpful because now we can perfectly center this string in the center of the screen. Sorry, I think this is really cool because I just figured out about that method not too long ago. So anyway, so let's draw this string perfectly in the center, as I said. So this will be unable to communicate with opponent string, and this will be at width divided by 2 minus the string width divided by 2, and this will be at height divided by 2, and then we will return. So, you know, that's really cool, and these are actually final, so these need to be capitalized. This will be height. And then we want to return, because we don't want to do anything under this. We don't want to render anything under this part if we are unable to communicate with the opponent. So, now more onto this render method. So if accepted, then we need to say for integer I is equal to 0, I is less than spaces dot length, I plus plus, and in here we will say if, what the heck, that thing's backwards. Alright, here we will say if spaces I dot equals, what the heck, goodness, x, then we'll do this. So if the space is equal to x, then we are going to have to do two things here. So if circle, so if we are circle, then do this, else if we are not circle, then do this. Actually, this can just be an else statement. It doesn't have to be an else if. So if we are circle, then we want to g.drawImage, and this will be a red x, right? Yeah, this will be red x. And I don't actually want all this stuff. We just want the simple method. Alright, so this will be a red x, and we are going to want to draw this at I mod 3 times length of space plus 10 times I mod 3. Then comma. Then we want to render at the y position integer I divided by 3 times the length of space plus 10 times the integer I divided by 3. And we will have an image observer of null. So, what this method here is doing is important. This is rendering it in the correct box on the screen. So we are drawing red x, and we are drawing this at I mod 3, and of course the modulus, the percent sign there, is the remainder operator, so 5 mod 10 mod 3 is 1, because there 3 goes into 10 3 times, and then as a remainder of 1. So I mod 3, so say we're at spot 5, so I mod 3, that would be 2 times the length of the space, and the length of the space would be 160, so 2 times 160, that's 320, plus 10 times I mod 3, which is 5, which I suppose technically, no, we're good, spot 5. Keep in mind spot 5 is this one right here. So then mod 3 again, and then times 10 plus 10. 10 was of course the length of the border here, was the length of these things. And so that will render it in spot 5 correctly. And then for the y, we're not doing a modulus. Instead, we're casting I divided by 3 to an integer because we want to round down. So like take I of let's do 7, spot 7. So let's just keep in mind where spot 7 is. That's this one right here. So so 7 divided by 3, that is 7 halves or 3.5. Which wait, no 7 thirds. 7 thirds divided by 3. Sorry. So that is 2.3333. So that will round down to 2 because we are casting it to an integer. An integer always rounds down. We'll multiply the length of space, which is 320, and then we'll add the same thing in again, and that will render it at the correct y position. So down here we want to draw a blue X, and now let's say else if spaces I dot equals O. If we are circle, then that will be blue. Else if we are circle, draw the image, back. So this will be a blue circle, and this will be a red circle. Alright, that handles rendering it in the correct spaces. So let's go ahead and hop out of that for loop. And let's say if we have 1 or the enemy has 1, then graphics 2D G2 is equal to graphics 2D of G, G2.setStroke, a new basic stroke of 10, and let's put stroke right back there. Stroke. We can go in and import basic stroke, and this is just setting the width of the line. This is setting the width of the line that will draw through from the first spot to the second spot, as I explained earlier. So we are setting it to 10 pixels big. So let's go in and do a g.setColor, a color.black, and we will g.drawLine between. Now this method here takes in an x1, a y1, an x2, and a y2. So we want to go ahead and throw in for the first one. This will be first spot mod 3 times the length of space plus 10 times first spot. Why do I keep putting length of spaces? Times first spot mod 3 plus the length of the space divided by 2. This next one, because this is y, we have to do the cast to integer thing again. So this will be first spot divided by 3 times the length of space plus 10. Oh my goodness, length of spaces, that's killing me. Plus 10 times an integer, or the integer cast of first spot divided by 3 plus length of space divided by 2. Ooh, now onto our x2 coordinate, which will be second spot mod 3 times the length of space plus 10 times plus 10 times second spot mod 3 where's mod? There we go. Mod 3 plus the length of space divided by 2. Then we'll do our y, which we have to cast to the integer again, and this will be second spot divided by 3 times the length of space plus 10 times an integer cast of second spot divided by 3 plus the length of space divided by 2. So that mouthful right there will render the line from our first spot to our second spot. Pretty easy, right? Okay. And I would highly suggest going through this method and trying to figure out how each part works, because I'm not going to go over that because we know what a mod does. This is just simple modulus and multiplying and addition. So I would highly suggest though going through that and like trying the different spaces. So like space 1 mod 3 is 0, or is 1, excuse me. So you know, just doing that thing there, or it's 0. Sorry. You know, just doing that stuff there so you can like get a good grasp of how that method there works. So then under that, let's go ahead and g.setColor right away. Alright, sorry about that. So this will be g.setColor, color.red. And we will g.setFont to our larger font this time. And we will say if 1, and then else if enemy 1. So in our 1 statement here, we will say that the integer string width is equal to g2.getFontMetrics of larger font here, which actually we already sent the font, we don't technically need to do that. Dot string width of 1 string, and then we will g.draw that string, 1 string, at width divided by 2 minus our string width divided by 2, and then at height divided by 2. In our else if statement here, and width and that are finals, I keep forgetting, those need to be capitalized. So if our enemy 1, then we'll say integer string width is equal to g2.getFontMetrics dot string width of enemy 1 string, and we will g.draw that string, which is enemy 1 string, at width divided by 2 minus the string width divided by 2 at height divided by 2. So that handles that part. So now all we need to do is finish off this rendering method with saying if neither of us have 1, then we will say g.setColor wait, no, not if we have 1. If we have not accepted, I want to jump out of that one. Here we go. So let's say else, so if we have not accepted, then let's do a g.setColor, color.red. We will g.setFont to font. We will do a graphics to 2D, g2 is equal to cast of graphics 2D to our G object, and that's just 1 font. And we will go ahead and say that g2.setRenderingHint to renderingHints.key underscore text anti-aliasing, comma, renderingHints.value dot renderingHints dot value underscore text underscore anti-alias on. And then we'll say integer string width is equal to g2.getFontMetrics and the string width of our waiting string, and then we will draw that string, so g.drawString, and this is our waiting string, and this is at, oh dang it, this is at width divided by 2 minus string width divided by 2 at height divided by 2. And this should be a semicolon. Alright, that handles our rendering method. So let's scroll around here and see what else we have left. Oh, of course, our check for win methods. Alright, we have to create something first. When I originally made this, I did this one thing where I'm like, oh, if space 1 is equal to x and space 2 is equal to x and space 3 is equal to x, then yeah, that's 1. Well, I figured out, the more I thought about it, that was stupid. So instead, let's go ahead and take a look at our board here. So this is 0, 1, 2, and this is 3, 4, 5, and this is 6, 7, 8. So let's instead create a private integer, multidimensional integer array called wins, and this will be equal to a new integer array. And so the first win possibility here is 0, 1, 2, right? That's horizontal. The next one will be 3, 4, 5. It's the other horizontal one. The next one I want to do is 6, 7, 8. That's the last horizontal one. Then we also have the vertical one, so 0, 3, 6. I hope you're seeing this. I'm just going like across and then down and stuff. the next one is 147, the next one is 258, and the last two are the diagonal wins, which is 0, 4, 8, and the last one is 2, 4, 6. So those are our win possibilities. I'll format that actually. So, oh, it screwed up my nice little thing there. I wonder if, can you do like, does this support HTML? Sorry, I just want to see if there's like a way to say that this is pre-formatted. Oh, will that really not? What happens if I remove these? Aha, how about that? It removes, allows these pre-formatted tags. Okay, brilliant. Can I do that in this? Will it still formatted? Yes, it will. Alright. Alright, sorry. Just the more you know. Alright. So, down into our check for win, check for enemy win, and check for tie methods. So the first thing I want to do is the check for win method. So this will be a for integer I is equal to 0, I is less than wins.length, I plus plus. We are going to say that if spaces wins I 0 dot equals how do I want to do this? Dot equals spaces wins I comma 1 dot no, you can't do that, and spaces wins I 1 dot equals spaces wins I 2. Is that method good? What am I missing? What's the error here? Save. Oh no, there's an error. Complete argument list. Alright, let's see here. Oh, we're just missing one. Boom. Alright, perfect. So if the first space is equal to the second space, and that the second space is equal to the third space, so all three of them are equal, then we can do this thing here. However, we need to check that they're equal to X, I suppose, or O. Depends which one we are. That's kind of frustrating. Could have created a Boolean array, but you know what? So, I guess, let's just go ahead and say, so if they're all equal, nah, we're not going to do that. I guess we're going to say, we're going to do an if statement here. If we are circle, then do this, else do this, and if we are circle, then if spaces wins I 0 dot equals this, and spaces wins I 1 dot equals O, and spaces wins I 2 dot equals O equals O, then we can do that, and we'll do the same thing here for Control Shift F, delete that, X, we'll delete this. Okay, that will do that, and so if they are all equal, then we can just go ahead and say that first spot is equal to wins I 0, and second spot is equal to wins I 2, and 1 equal to true, and we'll do the same thing right here. Alright, that will handle that method right there, and now we are going to do the exact same thing in check for enemy win, except we're going to check for X's, and here we're going to check for O's, and first spot, second spot, and this will set enemy 1 equal to true. Alright, that handles that method. So on to check for tie method. So the only way to get a tie in Tic-Tac-Toe is obviously if all spaces are filled and no one won. So we just need to check that every spot is filled, right? Because we'll call this method last after we call our both the check for enemy win and check win method. So we can go in and just make sure that every spot is filled. So for integer I is equal to 0, I is less than spaces dot length I plus plus, we will say if spaces I is equal to null, then let's return. Else tie is equal to true. We don't have a tie boolean. Oh my goodness, did I forget to create that one? Oh my goodness, I sure enough did. So private boolean tie equal to true. And you know what? Oh no, that needs to be equal to false. You know what else? We also didn't include that in our render method. How about that? So let's go ahead and also do a, I don't even think I have a string for this. Alright, well you know what, we should probably make that. Private string, tie string is equal to game ended in a tie. And let's come down here, down into our one. We're gonna go ahead and say if tie, then graphics 2D g2, which will be equal to a graphics 2D g2 dot, no, we just need to g dot set color dot black, and we will say g dot set font, and this will be a what font? I think the larger font should actually work for this. And we will go ahead and g2 dot get font metrics dot string width of tie string, and then we will g dot draw string, and that will be tie string, and this is x, so that is our width divided by 2 minus string width divided by 2, and this is height divided by 2. And I never actually created that string width, so this is integer string width is equal to that. Alright, so that handles the tie possibility. However, we never call the tie method, which could be a problem. We call the check for enemy win and we call the check for win method, but we have not once called the check for tie method, which you know is problematic because how are we going to know if it ended in a tie? So what we need to do is we need to call the check for tie method down in what do we need to check for this? We need to check for tie whenever we read the information or whenever we send information. So that would be, let's find this method here. Just control dis.read. So here, let's check for enemy win, and then let's check for tie. And then we also need a dos.write. That's down here. Check for win, check for tie. Alright, I think that should handle everything in this game. So let's go ahead and export this bad boy. Oh, I need to click on it. I'm like, well, why isn't it pulling up? Okay, export as a Java runnable jar file. And this will be of launch configuration Tic-Tac-Toe. And this export destination, let's go and browse. I'll put it on my desktop. No, I don't want a music one on my desktop. Oh gosh, Tic-Tac-Toe jar save. Alright, and we want to package the required libraries into generated jar, and then hit finish. So let's come out here, let's go ahead and pull up command prompt, and we will go ahead and try this, our game. So java minus jar, Tic-Tac-Toe 2, and this one will be our server, this one will be our client. Let's run that, let's run this. This one's the port, or the IP, excuse me, so that will be localhost. This will be 5.2s, this will be 5.2s, so let's see if it can start. Okay, good, it started that. Waiting for another player. You see how this text is like really nice and smooth and it's not pixelated? That's what the rendering hint thing was doing. Oh no, we did not successfully connect to that server. Sure, y'all see that? Thing's erroring like no other. Okay, let's close this out. Alright, let's see what the error was over here. Null pointer exception at render 140. And what did this one say? This one, oh, they both had it. Alright. There was a problem. Here, let's put these line numbers on. Toggle line numbers, show line numbers. So 140 over here, way up here. If spaces I dot equals x. Alright. So, ooh, that's kind of dumb. Seriously gonna do that? So we just need to check if spaces I does not equal null. Can't believe it wants you to do that. That's actually kind of ridiculous. But oh well. Let's make sure we don't use that anywhere else, I guess. Dot equals, I mean, it happens in this check for win method. Suppose we need to do it there too then. If spaces I does not equal null, then do this. And we'll copy that. We'll paste this. And we'll throw in another curly parenthesis. Alright, that should be good. So let's go ahead and export this again and see if it works. Nope, this one. Finish. Yes. Alright. I'm going to open 2 new fresh command prompts here. So right here, this will be Java -jar. This will be Java -jar. And we'll go ahead and pull in Tic-Tac-Toe 2. This one will be our server, that one will be our client. This will be localhost. This will be localhost. This will be 5 twos. Oh, that will be 4 twos actually, which I'm cool with that. Okay, that's good news. That's really good news. No errors yet. Thrown up, and there's our first error. Okay, unable to communicate with opponent. You see that? All right. So let's see what happened this time. Null pointer exception. Okay, in mouse clicked. I must have forgot one in mouse clicked, I guess. Mouse clicked. If spaces position dot equals. Ah, goodness. If spaces position is equal to null, or does not equal null, then let's run this code here. No. What do we want to do? If it does not equal null, except it will equal null. So why don't we just say if the position is equal to null? If spaces position is equal to null, then run this. So screw that part. Alright, export this again. Probably gonna be a few exports here, I'd guess. Alright, Java -jar. Java -jar. Java -jar. I'm actually gonna pull this thing down here. So Java -jar. Let's pull in Tic-Tac-Toe. And let's run this. This is on localhost. This is on localhost. It's on 5 twos. This is on 5 twos. Okay, good. Good so far. Alright, we got that. Let's throw in. Oh my gosh. Oh hey, it actually sent though. Didn't get it over here though. What was the problem? At 218, null pointer exception. And this was check for enemy win, Java null pointer exception. Oh, null pointer exception. This is ridiculous. Alright, so back at 214, what was the problem? So, second spots. Whoa, it shouldn't even be calling that. In reality. I suppose it could error out here. Spaces I. You know what? That's only 8. You know what? You know what? I'm going to change up. How do we want to do this? Java null pointer exception. Oh, it was at 218 first of all. Or this one was at 218 at least. That one was X. What was this error at? This one was at 232. let's do this instead rather than dot equals. So I'll copy that, paste it over that. So, yeah, okay, I see. So, this is our comparator operator. The dot equals is a method that will compare the string to the object, and it returns true if and only if the argument is not null. So, because our argument, or the argument could be null, you know, that kind of creates a problem. So, we are instead just going to use the comparator operator here, the equals equals. This one will probably work out better for us. Sometimes I find the dot equals method to be a safer operation for things, but not in this case, I guess. So let's go and remove these, and then along with that, I want to remove this if spaces I does not equal null check. So then down here, that should be fine. Alright, it should be fine. Let's export this again, and then let's export it another time, because I know this is probably going to fail. Resend. Oh no, it didn't even get it. Alright. Java minus jar. Java minus jar. Tic-Tac-Toe 2. Tic-Tac-Toe 2. Localhost. Localhost. 5 2s. 5 2s. See if we can go unscathed this time. I'll play right here. Okay, good, it got it. No errors. That's fantastic. Now it's this person's turn. No errors. Okay, brilliant. Okay, good. Ah, there we go. There is a working networked tic-tac-toe game. Alright, that's pretty much it. That was our network tic-tac-toe game. I will include a Dropbox links to the source of this project in the description. Please comment, rate, subscribe. Please tell me if I did something wrong or something you didn't like, and you know, we can figure out a way to fix that whole dot equals thing. Kind of frustrating, but that's good to know for future things. Just keep that in mind. Probably shouldn't be a problem here because we have the dot null equals check. But yeah, thank you for joining me. Learned a lot of good things in this video, like this pre-tag stuff. So yeah. Thank you. Please comment, rate, subscribe. The description or the source will be in the description. Thank you.